right, you're welcome back to the channel. Get to understand, don't memorize. This is a continuation of a series of lessons on binary operations. So in the previous video, we look at solve example on what on the properties of commutative property and what associative property. So in this lesson, we are going to look at solve example on this the distributive property. Okay, so this is a continuation of our lesson on what binary operation in further mathematics or elective mathematics. So this is an example we are going to consider. We said that, as we said, I hope you remember that the distributive property always what involves two operations and what three elements. We take three elements from the set on which the operation is defined, and then we use the two operations. Okay. So yes, so this is a real life example. Then there are two binary operations, square and triangle. So the operations are the two operations are square and triangle. They are all defined on the set of real numbers. Are defined. Two binary operations, square and triangle, are defined on the set of real numbers R, or the set of R, on the set R of real numbers by what? So you have x square y is equal to xy, where x, y belong to the set of real numbers, and you have what? So this is the definition for the operation of square. Then we have the operation of triangle. We have t triangle. R is equal to t plus what? T plus R. For t, R belonging to what? Belonging to the set of real numbers. Okay. And we are saying that question says that show whether or not I, the operation square, is distributive over triangle, and I operation triangle is distributive over square. I is the other, the operation square is what is associative. Okay. Yes. So in general, if we can say that if the operation if the operation triangle is distributive over what do you call it, over square, then we can say that here we have what, we have how many elements. This set this operation square defined on the set of real numbers with two elements, x and y, and the operation of triangle is also defined on the same real numbers with two elements, t and r. So you know that with distributive property we have two operations or three elements. So we can take the three elements from it. We have x, we have four elements, x, y, and t r. So we can take any three elements. Okay. Then we are saying that if the operation triangle is distributive over square, then it will mean that x you can have s triangle into bracket what? Into bracket s triangle y square t. Everything. Yes. So if the operation triangle is distributive over square, then we can say that if and only if what s triangle into bracket what y square t is equal to, so we are distributing, we have to distribute the square the triangle over square. So we yes. Okay, then the same this come to the, so if what x triangle what x triangle y to bracket all square and then what x triangle what triangle t. Have you seen? So the operation triangle is distributive over square if x triangle into bracket y square t is the same as what is equal to what x triangle y into bracket and then square into bracket s triangle what triangle t. Okay. Yes. So here, irrespective of the order, irrespective, I mean not the order, irrespective of the element you decide to take, somebody can decide to take what, if can say that the operation triangle is distributive over square if what, if and only t. So here I'll add for what, for all s comma y t belonging to what, belong to the set of real numbers. So somebody can also say that if the operation triangle distributive over square if what t triangle let's say x square r, if this is equal to t triangle x, then we have what to bracket r square to bracket t triangle r for what, for t comma x r belonging to what, the set of real numbers. Okay. So you can write it at this. So you only have to understand and know what you are doing. Yes, it's not difficult at all. It's very simple. And somebody can also write it as that. Okay. Yes. So very simple and hot and understandable, guys. Yes. So this is just an explanation. Okay. So let us look at the example and solve the example. Okay. Yes. So solution. we are going to solve. So giving what? We are giving what? First one is what? S square what? Sorry, S square. First one is x square what? Square y is equal to what? X y for what? X comma y belong to what? Belong to the set of what? Real numbers and what? And we have t triangle what? R is equals to what? T plus what? Plus R. T plus R. For T, R also belong to the set of real numbers. So yes, you can see that I. Okay, the first one. So this is the I. So the first one is what? Square distributive over triangle. So yes, the same. The only thing you need to understand. So I can say that the operation square is what? Is distributive. Distributive over triangle. If what? If let's say S square, we are distributing square over hot triangle S square y triangle hot triangle T. Okay, this is equal to what? S square hot S square y or triangle hot S square T. Okay, is what we have. So if you hear that, you know this square is distributed over triangle. West you have two square is here, square is here. So the square has been distributed over the operation of triangle. Okay, so we take this one first. Okay, you know that s square hot s square into bracket y triangle t. This is equal to what? Take this one first. This is equal to so s square. To bracket what is y triangle t? The definite triangle is what? This is a t triangle r is what? T triangle r. So here I didn't add it. You have to add this. For what? For x y t. S y t. Okay. Belonging to the set of real numbers. How to add this one is here. Supposed to come here. Okay. This is supposed to be here. Continuation. How to add that for that. Okay. Yes. So we take this one s. We are taking the left hand side first. Okay. So you have s what? X s square. Bracket. What is y triangle t? Y triangle t will be what? Y triangle t will be equal to what? Y plus what? Y plus t. So we have y plus what? Y plus t. Okay. So this is what we have. And then we come, this is what? X. So now we have x triangle what? Y plus t. So what s triangle y is sy. So you get this becomes x into bracket what? Y plus what? T. Is what you get, which is x y plus what? X what? St. Okay. Yes. Interesting. So we have finished with this one. We take this one. So that one we have x square hot square y. S square y, and then we have triangle bracket s square hot square t. Okay. So this is equal to, you take this s square. So s square y is sy. So s. So this one becomes s what? Sy bracket. Then we have triangle bracket. Using s square t will also become s x. Okay. Yes. So then we go to the operation of the triangle. This is triangle. Triangle t triangle r is equal to t plus what? R. So it means that x y triangle st, you get what? X y plus what? X what? St. Okay. Interesting. S y plus st. How do you see? This is equal to what? Is equal to this. Okay. They are equal. S y plus st. S y plus st. Hence, the operation square is what? Is distributive. Is distributive over what? Over triangle. Guys, I hope you are enjoying. This is not difficult at all. Let's just look at what. So we are going to I say that you have to show whether the operation triangle is also distributive over square. Okay, guys. Yes. So let us look at that in the next video. Thank you, guys, for watching. Okay, so let us continue. This is a continuation of what? Of our example of lesson on what? Solve example on what? Solve example on the distributive property. Okay. Solve example on what? On the distributive property. This is in elective mathematics or further mathematics. Okay, so yes, the operation we are giving s square y is equal to sy for s y belong to the set of real numbers, and t triangle r is equal to t plus r for t r belong to what? A set of real numbers. So I say that should show whether or not operation triangle is what? Is distributive. Okay, it's distributive over what? Over square, the operation square. So we say that the operation triangle is what? Is distributive over square. If okay, if t, let's say t triangle to bracket what? X square y, okay, is equal to t triangle x into bracket all square to bracket t triangle what? Triangle y, okay. That's for what? For instead of you can bring semicolon. We have t x y belonging to the set of real numbers. Okay. Yes. So if this is equal to this, then we say the operation triangle is distributive over the operation of what? Of square. Okay. So let's take this side first. The left hand side we have what? T triangle what? T triangle into bracket s square what? Square y. This is equal to t triangle. You solve the one into bracket first. So what is s square y? S square y is what? xy. So you get sy. This is what you get. Okay. So we have t. What is t triangle r? T triangle r with t is t plus r. So if the whole of xy is just like r, so you get what? T, which is equal to t plus what? xy. Okay. So this is the answer we will get. Okay. So then we take what? We take the right hand side. Okay. Yes. So we have for the right hand side, we have also we have t triangle what? T triangle x. Okay. Then square to bracket t triangle what? T triangle y. Okay. Yes. So this is equal to solve this one. So t triangle t, since t triangle r is equal to t plus r, it means that t triangle x will be equal to what? T plus what? X. So this is what we have. Then bring the operation. The operation of what? We have the triangle square. Okay. Then to bracket this one t triangle y. That one with t plus what? T plus y. Okay. So yes, we have this and this. So what do we get? We have this one. This becomes t plus s to bracket square t plus y. So what is s? Triangle y is the s square y is equal to xy. So this becomes what? T plus x times what? T plus what? Y. Have you seen? Definitely. This why you know that this, if you like, you can expand that. You know that this one is never equal to, which is not equal to t plus x what? Sy. Have you seen? So you can say, conclude by saying that hence the operation, this operation triangle is not what? Is not distributive. Distributive over the operation of what? Square. Yes. Yeah, I'm glad you are enjoying. Okay, the third one was saying that the III was saying that you determine whether this operation is what? Operation square is what? Is associative. Okay. So you let s y t belong to what? Belong to the set of real numbers. Then the operation then the operation is what? Associative. Okay. It's associative. If what? If s square x, sorry, if s square y square what? Square t is equal to x square y square what? Square t. So here you evaluate the first two, and over here you evaluate the last two. Have you seen? So this one is what? This is equal to what? This side is equal to x square y, which is what? xy. Okay, so you have xy, then square hot square t, so it becomes what? X y hot yt. This is what we get. And then this one also, x square bracket y square t will be equal to what? X square into bracket y square t will be what? Yt. So x square into bracket yt is equal to x y hot yt, which is equal to what? Which is the same as what? Is the same as x square y square all square hot or square t. This one. Okay. So syt. Okay. So you say that hence the operation square is what? Is associative. Guys, I hope you are enjoying. This is not difficult, very interesting. Hope you are enjoying. How can I know you are enjoying, guys? I can only know that by keeping your comments coming in, by subscribing, and by sharing with your friends, sharing the links and liking. Well, liking it. Don't forget to subscribe, guys, so that if understandable and well explained examples like this are uploaded, you'll be automatically notified. Guys, thank you for watching and see you in the next video.